lost weather balloon. An Air Force spokesman confirms tonight that this was no flying saucer.
Anwendungsmöglichkeiten dieser Naturerscheinung patentrechtlich geschützt seien, hat sich geirrt. Der heute 52-jährige Maschinenbauer Friedrich Luling aus Schleswig-Holstein schuf bereits 1954 die Voraussetzungen für den Dauermagnetmotor. Inzwischen glaubt er seine Erfindung so weit vervollkommnet zu haben, dass es ihm an der Zeit erscheint, den neuen Motor in der UFA-Wochenschau zum ersten Mal vorzustellen.
Es ist mir entgegen aller herkömmlichen Kenntnisse über den Dauermagneten schon 1954 gelungen, Dauermagneten zu neutralisieren. Der rotierende Anker wird von dem Magnetsystem angezogen bis kurz vor dem Punkt, wo er ihn festhalten will. Im selben Augenblick setzt die Neutralisierung der Magneten ein, sodass der Anker ohne jegliche Rückzugskraft
This is the learning tool that I have put together for you guys in order to understand in detail about the neutralization of the magnetic field forces. Okay, and the way the magnets are set is exactly as I have shown on the graphics. This is a north and this is a north too. And the static on the stator is also a north, and I have chosen the south to do the adjustment with this tool that I have created. And it's just a bar here, a steel bar with a thread that I can pull the magnet back and forth through a spring, a return spring. And you'll see what the spring is for. I have underlined here specifically the bisector of all four magnets. And the bisector divides, it's perpendicular to the block wall, okay, the center division between south and north. So the bisector is perpendicular, and this is the perfect line. This it might look a little bit full of holes because it comes from previous tests on other magnetic motors and other models that I have built over time, over years. And it's gotta be very precise. You can be playing with wobbly discs and off center in order that it give me a gap here, and then it's like moving the disc is not center. It's gotta be perfectly center, a high speed in a torque, in a lathe, and be shaped so in order that it's almost perfect. And I have used aviation nuts in all the adjustments in order to prevent from any getting loose, because it's gonna throw off the whole thing. If a bolt becomes loose and I start tilting a little bit, a little tilt, 0.5 millimeter off the center of the alignment, or the linear alignment, it's gonna throw off the whole thing. And then you're gonna feel one side is feeling different than the other on the rotor, and that's gonna become a nightmare. So everything has to be measured from the center of the shaft to the end of the magnet, and between this magnet and the face of the other magnet. Basically, I use for reference this magnet here, the steady one, the fixed one. And then I try to duplicate it here, but then it's got a play that you will see now. It's about 0.5 millimeter, 1/3 of a millimeter move. It'll alter the feel that you get when you're rotating it. Okay, so right now I have it adjusted at max loose, which means the magnet is at its maximum closer gap. It's closed. So it's very sticky right here. You see, it's very sticky. So, but it's still, want you to watch this, it can turn. Okay, it can turn. And not that hard, but if I let it go in a slower motion, it'll stick. But see that? Okay. Now, as I start, and I want to watch on this part carefully on what happened with the bisectors here, basically. So you can see right there, they are almost aligned, but as soon as I start bringing the magnet back, the south pole, see how the bisectors start on the rotor, start deviating to my left, this way. And the more I get the magnet back, and the more it gets off center towards this way. So right now it's even softer. It still have a sticky point, but then will be a point where you start feeling more the repulsion than the attraction, and that's where you have to stop. So until you hit the sweet spot, there is a sweet spot that is only, believe me, it's a hair. It's a very tiny, narrow, tight adjustment, and that's when you know that you're getting. So don't be rude on this. You gotta. This has got a 10/32 thread, which is pretty fine, and I did it in order not. I didn't put a heavy coarse thread in order to be able to run it more precisely. Right now it's pretty loose, see, but now it's encountering. And that's another thing. Magnet 1 on the rotor, see where it's falling. Magnet 2 should be on the same edge. If it's not on the same edge, there is something wrong with the magnet's alignment between them, between center to them. They're off, or they're tilted, or there's something wrong. But they both has to come exactly at the same point. Okay, and the more you get the adjusted magnet backwards, the more this will displace, until there's a point that there's almost nothing feel here. It's like, I think I went too much, so I'm gonna go forward, loosening it, the nut, the thread, and right now, see, it's very smooth. Now, if I retract this magnet on here, I will retract it, and I have to hold this. See, it throws the force. And the tighter I get it to the starter magnet, the closer I get it, the more throw out. I use that word on my asymmetric machines. The more throw out you get. So the harder you push here, see? So that is what we're looking for. That's a throw out force. And it went 2 times. And the harder and the steadier, the spring will bring it back to neutral point. That's why it keeps running. See, and that's the whole secret of it. And I can even get it tighter closer, as you can see right here, and I can pull it and I get more impulse. So the tighter it is to this center, the more force I have to apply, but the stronger the rotation will be. And of course, this has to be done every 180 degrees, exactly. So if we do it, I cannot do it by hand. I mean, you can try yourself doing it by every 180 degrees, but it's very hard. You don't have the precision. Only a machine will do that. And anyways, this is basically it. I'm just gonna release it back to a little bit off. Now here is not recommended for the motor. Why? Because the throwout force here to spin the rotor is going to be very weak. It's going to be lesser force here to be applied, but it's not going to be that much of a force. You can try different tests, but it's not going to be much. See? That's not much, and so on. Because I have the camera in between me, I cannot actually show you. Let me see if I can position in a better way. See? And that's the idea of the motor. Now, this is, you're gonna watch this learning tool, how I get it into a motor, going 400 RPMs after I use the Luling technique to break this with the proper equipment and the proper components. And this is it. Okay, here it's, to me, this is the more important testing of this motor. And this is, I just have one actuator rod here, which is going to be turning just one magnet of the rotor. And that magnet is this one here. When it hits the valve, just this magnet right here is gonna be propulsing the rotor. When this one comes here, it won't have an actuator. Okay, so the cylinder will not actuate, the valve will not send any signal to the piston, so it's only halfway, or a 1-to-1 ratio. It is supposed to work with two actuators, so the two magnets in the rotor at 180 degrees are propulsing evenly the rotor. This test, it shows that only one magnet and one magnet in the stator is able to close the 360 degrees loop and keep a rotation. Keep a low speed rotation because we're going halfway, but still we are closing the loop and clicking, you know, once per RPM or 1-to-1 ratio. So one magnet is in charge here of running, of spinning the rotor. And of course, don't notice the RPMs are gonna be half of what is supposed to be done, about half of what's going to be performing with two actuator rods. Sorry. So here I already connected the air. It's already on the valve. It's 120 psi, and I'm just going to spin it. And this is amazing. It's only one rotor. And one rotor is able to make it go 325. This is a very good way when you're putting together this motor, this setup, to run it with one, because that'll tell you exactly your timing points and where to set the timing, the correct timing to gain more speed. So you adjust the gap here, of course, with this forward to check the gap, and that's air is still in the line, in the hoses. So to adjust it, to get a better, until you get the better RPMs, then you set at 180 exactly the other one, the other actuator rod, and that'll get you a much robust rotation of this motor. And this is my first test. When I did this, I was very excited that I see that not only I'm closing the loop, but I'm closing the loop in a very strong fashion. And yeah, it gave me a lot of hopes, guys. This is what Lüling was about to show us in 1966, and for some reason this thing got disappeared. Anyways, I'll be showing next the two full actuator rods. Okay, so here we have the basic prototype that I have used on previous videos, or the learning tool, how to obtain kind of a neutralization process. I'll go over again, but this is the same, except that I right now have the two rods, the two actuating rods, activating the valve, the two-port valve, input and output. So that means that both magnets will be contributing to the rotation process. Not like before, that only one magnet was on the process, on the rotation. I have connected the air, and we can see right there we have 120 psi pressure. And I have put a valve, a close-up valve, which is closed right now, and that goes through another gauge, which is closest to the motor, and that is going to be showing the pulsations of the air coming in and out I'll go over this real quick. This piston right here, it's a return spring, single acting rod piston, and it'll be pushing about half-inch, exactly half-inch backwards, and giving the propulsion to the motor. Now the rotation of the motor is going to be higher if we look at it counterclockwise. This will be faster. Why? Because let me get it close up here. The bisector right here is triggering at a much closer angle. See, right there is triggered at a very narrow angle. However, when it goes this way, if we go that way, meaning clockwise, it'll be triggering further away in a wider angle. That's the reason why it's going to produce lesser RPMs going clockwise and much higher going counterclockwise. So it's going to be a demonstration of, if I leave it right here, the motor will start and it will start going clockwise if I open the faucet, the air faucet. And I'm going to just do that, and you watch the motor while I turn on the air. And I just turn off the air, and we can see how strong the rotations are, even though it's going like 200 RPMs, 200 and some RPMs. Now I'm gonna open the gas again, the air, and we can see here this valve, this gauge right here, and I'm just gonna turn it, and I'm gonna get this reading, which it reads right here. I have set right here the marking for the tachometer, and we're gonna see. I have to hold the motor because it vibrates and it's not anchored anywhere. You can see it's completely off, and I'm gonna just set up to go counterclockwise. So it's about 415, and sometimes if I get the tachometer up, it's gonna get the measurement from the reflection of the magnets, which will be double, 600, 800 RPM. So that's a false reading. It's normally like 400 RPMs. What the motor is going with just 2 magnets, and of course we're seeing right now a ratio of 2 actuations of the air piston per 1 RPM, and this is normal because it's going 1 where this magnet will be the one disconnecting. This magnet right here will be disconnecting because the piston will be back. It will be breaking the neutralization, and then this magnet will be in charge, the repulsion right here will be in charge of pushing the rotation, and so on. This magnet, just this magnet, will be the one propulsing every time of the rotation, even with the 2 actuating rods, one at a time. And twice, 1 magnet per 180 and the other magnet 180 degrees. And this is the setup. I'm gonna do a few demonstrations now showing that I can stop the air, regulate the air, and so reconnect it again, and the motor will keep going. So to demonstrate how fast it turns. So here I am. I just pushed it. I just turn off here. And it gets up. I disconnect here and it starts getting speed again. So we can see how strong it runs on permanent magnets, and I want to go over this system so I refresh everybody's mind here. The piston is actuating the air piston based on the opening of this valve. This is just the simplest setup that I can show you guys. And this is just one module of the 4 that Luling has on the motor, except that he has them like this. And he has one here, one here, one here, and 4 modules. And he uses just one actuator because he uses a rod to transmit, a rod and a shaft that you can see on the video to transmit the pivoting back and forth, the reciprocating movement along the 4 modules, which means that Luling has his motor running at the same, with the same timing, with the same exact timing for all 4 modules, and which is great. It gives a lot of torque, but a lower RPM. Of course, Luling did not have neo magnets in 1966. He had ceramic magnets and maybe magnets that had especially been made, magnetized. But the neodymium boron and all the new materials that we have right now, like these are N52 grade, are much higher. And here I have a huge air gap, which is about 4.5 millimeters, and to be on both sides, to be regulated and in order to achieve neutralization. And I want to clear something about neutralization here. It is neutral, but it's got a sticky point, and it's got to have a sticky point. Otherwise, there won't be strength when I pull this magnet. So I want to show you what the motor, the air does is just pull every 180 degrees in a steady fashion. If I get it this way, it'll go that way. If I pass the bisector off to that way it'll go counterclockwise. So, and so on. Right here is the setup point, the resting point, which is going to the left clockwise. But the return of the back to neutralization is what allows the magnet to keep going freely. I see it exactly as the description that we get on the video from Lüling. It is identical. All right, guys, thanks for watching.